Hello, my name is Dr. Doug Brown, and I'm the Chief Technology Officer and co-founder here at Zs2 Technologies. At Zs2, we believe in building sustainably and for a resilient future, and at the core of resiliency is cement. Cement is so ubiquitous that it's almost become invisible to us, but is the second most consumed resource on the planet, only behind fresh water, and so its use is extremely prolific. It's extremely durable and strong material, and so we see it as a core building block for building for a resilient future. Next slide. The downside of cement is that it's extremely carbon intensive, and that's because it's based on limestone. Limestone is a rock that's absorbed CO2 over geological timelines, and we're reversing that process. And it's extremely carbon intensive. In fact, this material accounts for about 8% of all anthropogenic CO2 production in the world, a number that's set to grow to almost a quarter of all emissions by 2050. And so the question of cement in our future becomes prevalent. Next slide. When we look at the building environment and the challenges around it, the building industry and materials account for almost 39% of all global CO2 emissions currently. Over the last 5 decades, the operational efficiency of buildings, i.e. the operational carbon footprint, was the most important part of the piece of the pie, i.e. the life cycle assessment. That's just not the case anymore. With our advances in building science, we've come to almost equate the embodied carbon, or the carbon footprint of the materials that go into the building, as almost equally as important to the operational efficiency of that building over its, say, 50-year lifetime. And so the piece of embodied footprint, which comes back to cement, becomes extremely important. Next slide. We need alternatives. We're building for a climate change future where common disasters are becoming commonplace. These come in the form of fires, landslides, floods, and right now the status quo, or the building codes, allow for only human safety. So the building is meant to survive the event long enough for people to escape. But then when you come home, you've lost everything. And so we need to become more advanced than the building codes currently established. Next slide. At Zs2, we're based on a technology that's magnesium oxysulfate, or saltwater-based cements. We currently sell and manufacture tech boards and tech panels. These materials are to replace OSB and drywall as a common sheathing material in your construction, and then our panels would actually replace your entire building envelope. These materials are extremely fire resistant because by mass they have almost 60% water locked into them. Excuse me. By mass they have almost 60% water locked into them. The fire resistance of these materials can be up to 3 hours based on the client's intended use. But not only that, magnesium oxide exhibits antimicrobial behavior under ambient conditions. And so if you have a flood issue or something like that, you're not necessarily going to come home to a basement full of black mold. These materials, because they have a tremendous amount of salt water in them, are extremely sustainable and have a much lower carbon footprint than conventional cements. Next slide. We think this is a solution that is very well suited for affordable housing in Calgary. And the reason is because if you look at the site impact of various sort of solutions, when you have more prefabricated components off-site, you're not going to have noise or environmental impacts or minimized of job site construction. We can take different levels of design, everything from a napkin drawing to the conceptualized engineering drawings of a project. Then our design team will take these projects, 3D render them, and 3D cut all the components for the building envelope, including door openings and door windows. We rapidly construct these, and we can flat pack them and ship them on site. And so this decreases construction times and gets people in houses quicker. Next slide. Our building envelopes, because everything is prefabricated and designed, are extremely energy efficient because they have extremely tight building packages. Again, these materials are also fire rated and non-toxic. The major off-gassing of these materials is H2O or water. So they're essentially non-toxic. The other two building components, magnesium oxide and magnesium-based salts, are things that you would either take a bath in or consume in a vitamin. And obviously this is a simplified level of construction on site because we take the complexity in our manufacturing. Next slide. So we believe it's time for change at Zs2. Building codes are set to the minimum standards, and we spend most of our lives in buildings, and so this is really something that we feel very strongly about moving forward. Next slide. At Zs2, we're extremely socially and environmentally conscious. We're in the process of completing our environmental product declaration, which is a third-party verified life cycle assessment of our entire process and our technology. Early indications suggest a significant reduction in the carbon footprint, as well as landfill waste, based on being able to prefabricate all the components and optimize the use of all the materials. We're also in the process of getting our B Corp status, which really focuses on social governance. But we see the biggest opportunity for Calgary around the future of development of our products. So currently we internationally import our magnesium oxide boards, but we're focused now on generating these materials here in Alberta using two major waste streams. One that's generated as a mined waste, where we gain our MGO, and the other is a petrobrine waste, where we've partnered with a few different oil and gas companies to look at using their brine waste in our new saltwater-based materials. And so we see this as a really important part of Calgary's path forward. Next slide. The opportunity is really endless. We pump more saltwater in this province than we do brine. We have a huge amount of expertise in looking at underwater or subsurface reservoirs. And so we think that there's an extremely good opportunity for this workforce to be repurposed into saltwater-based cements. Next slide. And I'd be happy to answer any questions.